Hello everyone, so I'm Hakoub and I'm going to talk about testing Terraform modules today. So I'm sure we all know what Terraform is, but just quickly, it's probably the most popular infrastructure as code tool around so that we can deploy our resources in the cloud or anywhere else. And in Terraform, we have this thing called modules when you group your resources, let's say per workload, and they become their own testable and deployable unit. So why do we need to test modules? Because they're code, just like any other code, and we need to test them before we deploy them. And a lot of times deployments just fail. There's a variety of reasons why that happens, including from cloud provider API issues, naming conflicts, and other things like that. When we're building infrastructures, we receive requests from different teams for environments. The first thing is usually for dev boxes, so that the developers can write their code. And just as you start working on that, you get another request for network because you realize there is no network in the company still. You're just trying to build software and there's no internet. And then you need a model for that. And later you get another request for an application that needs to be launched to the cloud in a couple of months to have model for that. And then you need security around all that. And then you have another app, and then you need monitoring. So each of these requests, each workload becomes another module. And if you're a team lead or a manager, sooner or later you'll have to deal with a lot of pull requests for these modules, and you need to review them. But how do you actually know they work? One of the ways is to have browser extensions, not browser, like IDE extensions that actually do some checks for syntax and things like that. And I've seen intro requests where you have a trust-based system where the developer of the module just says that, yes, I did deploy this code before opening the pull request and some other manual verifications. But obviously that's not enough. And before we merge the code, we need to actually deploy it. One of the ways is, of course, you can also just check out each branch and have a deployment before you actually approve the pull request. But I don't think anyone wants to do that, especially on scale. So we need something better. But before we move to the solutions, let's go over some of the reasons for deployments to fail. In this example, this is just a simple storage account in Azure. And I'm hinting here that the issue is with the name. No matter how much we read about the documentation, like what the naming conventions are, there are still some things that we're gonna miss. And especially in Azure, it's a very complicated naming convention where each resource has its own rules. So can anyone guess why this is going to fail? It has, good. The hyphens. Yes, you're right. For some reason, we cannot have hyphens, dashes in the storage account names, although many other resources allow that. In storage accounts, you can't have it. So this will basically fail to deploy. And let's say we remove that and we remove the hyphens. Why else could this fail? It's also related to the name. Yeah, exactly. Because some resources are limited to 24 characters. Some resources are limited to 60 characters. Some resources, I think, 100. Nobody knows why. I don't know. There's a huge document online that goes over all this. But again, I personally don't want to learn that. I don't want to know that. I don't want to spend my time and energy learning about the naming convention in a specific cloud. So again, what can we do? There are other ways to solve specifically this naming problem. There is a very good provider in Terraform, which lets you enforce naming rules on the modules, but you cannot actually force everyone to use that module. So you need some policy checks around that, which is something we should have anyway. but still it doesn't completely solve the problem. Just like any other solution, it moves the problem elsewhere. So it's not a complete solution, and we need multiple solutions for this, at least in my opinion, from my experience. Okay, yeah. Also, they need to be globally unique, just for the record. Yeah. Next, I think we mostly went over it. Okay, other than naming, we have CPU quotas, regional availability. For example, AI services are available on one region, but not available in a second region. You have unregistered resource providers. You have to enable the services. You can have, of course, overlapping network ranges. You can have missing permissions in the service principal or the application that is actually doing the deployment in the cloud. And ordering issues, like missing depends on conditions on the Terraform resources themselves. Okay, so I think now we know that we need to solve this problem somehow. But this is like everyone should have this problem, right? There's someone must have solved it, and a lot of companies actually did solve this. For example, Terra Test by Groundwork. It was released in 2016. It has been around for a very long time, so it's very mature, and you can pretty much write any test with it. Also, it works for Terraform, Packer, Kubernetes manifest, Docker. But the problem it has is that it's a Go library. So you have to actually know programming. Maybe I know, maybe a lot of people on the team knows, but not everyone on DevOps, SRE, or platform engineering teams actually know how to code, or it's not really a requirement. So it's more, I would say, a developer friendly tool. Yeah, in the real world, it's just not realistic to rely on this because not everyone knows programming. The other solution I found while researching this is called Kitchen Terraform, which was released in 2017. It's a plugin for Test Kitchen. Those are, if you're familiar with it, it's an inspec and Ruby. It uses Ruby. It's also good for teams who are already familiar with Ruby and the entire Chef ecosystem, and it's deprecated now, actually. So those are the first two. But then, of course, we have the native solution from HashiCorp, which is Terraform Test. It's just a command. It was released in 2023 with Terraform 1.6. The obvious advantage of this is that it's the first party solution from HashiCorp, right? The tests are right in HashiCorp configuration language, so you don't really need to learn a new language. If Terraform, you'd be familiar with it. It's ephemeral by design, so we don't need to handle destroying the environment separately. So when you actually run Terraform test, it deploys and destroys the environment automatically. So you don't have to worry about that. It generates costs, but it's something, I think it's some costs that we have to accept because they're very short-lived. And you can also do what's called plan-only test, where, as the name suggests, it only plans, it does not actually deploy anything. But I don't see it. Ephemeral is good, but I still want to have, I want to control how long that environment lives, because no matter how much automation we have, we still have to sometimes just SSH to the server, just RDP, or do just manual checks, or maybe test the application itself, or maybe run other tests before we destroy the infrastructure. So it's very good, but it didn't give me the flexibility that I really wanted. Also, you actually have to write the separate test for each resource. So it's very similar to unit testing. But again, after some time, I think it's going to be unmaintainable. Not everyone is going to be a unit test. I mean, we can enforce that. It's going to just make things harder, I think. It will be a huge investment, at least in my opinion. Okay, yeah. So we talk about ephemeral. Yeah, also, it's a separate framework with its own learning curve bugs and issues. So even though the language is the same, it still has a specific learning curve that you have to learn how to write the test. Okay, so what is my approach? What am I suggesting? So what I did is I just created a multi-stage CI/CD pipeline, which runs just Terraform plan, apply, waits, and then destroys the environment when you want it to be destroyed. It's as simple as deploying any environment. It's basically zero maintenance because there's no separate code developed and everything is handled just under one generic CI/CD workflow. So all the modules use the same pipeline template, at least it's the same workflow. As you can see, it's a very simple, I think there's nothing specific here. It's just an instantiation of the module. It's called test. We load the module with its source and we just pass it a parameter called environment. And this variable is actually auto-generated in the pipeline. It's just a three-digit number so that it's unique for each deployment because we don't want to have overlaps in naming and other stuff. We need to be just uniquely identified. So your test is essentially just the deployment of the module, but it's automated in CI/CD. Okay, so when we're designing these pipelines, what are the requirements of this system? We have three main users here, 3 points where we gather requirements from. The first is DevOps engineer, the Terraform model reviewer, which could be platform engineering manager, another DevOps engineer, and there's also the software engineer or the QA who would want to deploy the model just to run simple tests, for example, if they're developing a new feature. So I would like to have a pipeline that on demand or based on triggers deploys the module in an isolated environment so that I can verify that my module code changes do not break deployments and the resources work as expected. And as a reviewer, I would like to module to be deployed when a pull request is opened so that I can approve the changes with more confidence. Last but not least, as I said, this can also be used as a self-service platform so that software engineers or QAs can deploy a tiny environment just to test something very short-lived. Yeah, this is specifically useful for feature testing before the code is merged. Okay. So what does that look like? I had this implemented in Azure pipelines, but I'm pretty sure we can implement it in 70% of other solutions. So we have, in total, we have 6 stages. So from 1 to 2, just check out the repository, initialize the Terraform module, then create the plan to deploy the infrastructure. Even though this is just testing and it's an isolated environment, we still just need to review the Terraform plan before we apply it, just a safety measure. So once that's reviewed, approved, and then to deployment. After that, I ran this 4th stage automatically, which is the plan for the destroy of the infrastructure, not the deployment. And it just stops there. As you can see, this 5th stage depends on 2 previous stages. One of them is the plan, and the other is the trigger destroy. And this trigger destroy is the step that you have to manually run it so that once you're done, once you're satisfied with the deployment, you check the resources in the cloud, you need whatever you need to do, you just run this stage manually so that you could just destroy it and complete the pull request. Yeah, and this is a multi-repository pipeline. We have the first repository, CI/CD TF mod, which is the module, and the second is the tester. It just checks out other repositories and contains the template to the pipeline that is used by all modules. Okay, this is just a screenshot showing the run stage, which stops here, and this is a manual stage. And again, even though we should not have manual stages, this is just one of these cases where we should not automate everything. Some things just need to stay manual. But it's just about that. Okay, so what does the implementation look like? So this is the template of the pipeline. It takes parameter for the name of the module repository. We call this and we pass it whichever model you want to test. And we have some simple PowerShell to generate a random number, which will be used for the environment ID. That is then passed to Terraform, and it's also used in the state file for Terraform because it needs to be unique and it still creates a state file in the cloud. What I don't have yet is deleting that state file. That's just something we're dealing with still. Okay, so that's most of what that looks like. Also, I'd like to just mention local stack in case you're not familiar with it. It's an emulator that allows you to run your cloud services on your local machine. So you can actually deploy your model locally, just like a developer would build their code or run the unit test locally before actually pushing the code to the repository. It supports a lot of, mostly it supports AWS and Snowflake, but also recently they added support for Azure. It's widely adopted in the AWS world and very effective for AWS. As a general advice, I recommend trying to keep your infrastructure as code as simple as possible. It always starts with a couple of VMs, maybe Kubernetes cluster, maybe some other services, but it gets complicated really fast. Don't use a lot of complicated for each loops and the conditions and a lot of the advanced stuff in Terraform. I think they need to be used with caution because you cannot test it. You cannot predict their behavior once it gets complicated. Because after all, HCL, HashiCorp configuration language, it's a configuration language. It's not a full programming language. You can do a lot of advanced creative stuff with it. A lot of time, I don't think we should. There are other tools for that. And we can, if we can keep it simple, let's just keep it simple. And it's okay to create separate modules and separate repositories for each percent workload. The reason I'm mentioning is because in a lot of teams, I had this problem that, okay, at some point we might have 100 repositories and 100 modules. That's fine. It's better than having one when you have to search for hours to understand what's happening there. It's okay to have a lot of stuff, as long as you can logically separate the purpose and the workload. Another note, do not rely too much on any cloud provider because one day you might have to migrate and it's going to be a painful process, like especially if you have terabytes of data, especially if you have a lot of reliance on very cloud specific services. So I would say try to stick with either VMs or Kubernetes. In my experience, we went from VMs to PaaS, like serverless, for speed and the like running away from the learning curve of Kubernetes. But eventually, you'll get involved with Kubernetes anyway, and I know it's scary at first, but it's not that complicated actually. And at the end, especially if your workload is simple, it's much simpler to run it in Kubernetes than to use a very specific PaaS because the tooling is not really there. Yeah. And when you search for something, sometimes you just feel alone. It's more developer friendly than for infrastructure engineers. Yeah, but that doesn't mean we should not use PaaS, of course. Let's use it for storage, for databases, for anything that includes data or state. I don't want to deal with that a lot. That's something I would rather delegate to PaaS, for example. Okay, that's it from me, from the presentation. Any questions?
All right. So, do we have any questions? Raise your hands. Let's come here so I can see if anyone raises their hands. There seems to know. Oh, there's two questions. Okay, so you go here first.
Okay, thanks. So I'm wondering, so when we're following the approach of just having a pipeline running my Terraform module to test it out, how do I balance out the time it will take to set up the whole infrastructure if I'm doing it from scratch versus, I guess, having some infrastructure already in place, but it's always there and always paying for it? How do I balance out these decisions on where should my test start? Should I start from nothing or should I have some kind of base infrastructure in place all the time?
For the model testing, you don't really need to do that because the way I design the modules, you can have something like self-contained mode in the module so that it does not rely on any existing infrastructure before it's deployed. For example, not all modules should deploy their own network, right? So you should have some network that it connects to. We better deploy that in the module instead of relying on another layer. In my example, that's how I did it. Yeah. For this, like in Azure, you just need a subscription or the account, and you should not assume anything exists beforehand because you run into the problem of versioning that maybe that is old and my module does not work with that, and you have to go change that. So it's better that the module works by itself and you have contracts between separate models. For example, if you have a security team and another team, this should be like contracts between the teams and the modules. Yeah. Thank you.
Yeah, thank you. Thank you for the presentation, first of all. I have two questions actually. The first one is regarding one of the tools that you showed, that is TerraTest, I think. I was wondering, you mentioned that it is able to test Docker files. It is easy to manage and to develop tests for our Docker files. We're using that tool. Do you have experience on that, or just curious?
Yeah, thanks for the question. I don't have experience specifically with Docker, but I know that you can do pretty much anything you want with it as long as you're proficient in Golang. Yeah.
Okay. And the second question is regarding the last tool that you showed, the local stack. I was wondering, it's easily applicable. We can just run a local stack and apply our Terraform scripts to the local stacks for testing purposes.
The state, yeah, it's local. It keeps it local. If you're running Terraform test on your local machine, it does not need a remote state.
No, I was wondering, we can apply the resources to the Terraform resource to the local stack, right?
Local stack,
Yeah.
yes, you can. As long as Terraform is concerned, it's the same thing. There's no distinction between them.
Okay, thank you.